This is the Artful Skeptics channel. Here I've got ProPanda. Hello, Panda.
Hola.
And today we have Holly, who will be discussing with us the model for the flat Earth. Holly, would you like to give us a brief introduction about how you were introduced to the flat Earth model and what caused you to be convinced by it?
Yeah, absolutely. Sure. It was actually about 2 years ago, and I was online and I came across something actually that was about, it wasn't about flat Earth, but it was about, it said giant trees. There's no more giant trees on flat Earth. I mean, and anyway, so I watched that because that just caught my attention, and I thought, their stuff was just absolutely ludicrous. I've heard about it first when I was in school, in grade school, but that's the last time I had heard about it was when I was in early education. And I thought it was insane, but something about it caught my attention, and it was some things about the facts about the heliocentric model. So I just wanted to check them out to make sure that what they were saying wasn't true. And it turns out that what they were saying was indeed true. And I've been hooked ever since.
Okay, great. What's it like with people in your community who you speak to? I mean, do they give you grief for it, or do they understand?
No, I've gotten a lot of grief for it, a lot of ridicule, some really harsh ridicule, and a lot of negativity. And I would say just recently, like in the last 6 months, for some reason, I'm getting a lot more positive feedback from people, and it's really been wonderful and refreshing. And it wasn't what I expected. I knew when I got into this, I expected the negativity, but I thought maybe if I could reach somebody, just doing what I can. But there's been a lot of positivity lately.
Yeah, sure. There does seem to be a significant rise in people who accept the flat Earth recently. Anyway, for this one, ProPanda will be taking it from here, and I'll be sitting in the background. So, by the way, just before we start with the conversation on that, what would it take for you to be convinced of the heliocentric model rather than the flat Earth model?
Well, it would have to be accurate.
Accurate. Okay, fantastic. Okay, Panda,
Yes.
it's all over to you.
Yeah. Okay. So I guess my first question would be, do you accept the theory of gravity? What's your opinion on that?
No, I do not. And I have read and studied in depth the theory of gravity and the original works that was done to basically be the basis of theory for gravity. And no, I think it's just absolutely ridiculous. And I don't think it's not based in anything realistic or reality at all.
Okay, so then what is the force that keeps us all glued to the planet? What's that?
See, that's such a great question, and the whole thing is that question, if you understand the flat Earth model, you realize that you are asking questions that are unnecessary, because the Earth, the Earth is flat and it's stationary, so there's not a specific need necessarily for something to be holding us on to the so-called planet, because the Earth is flat and stationary. We're not gonna fall off. If you go up on a mountain, you could fall down. We understand that. We know up is up and down is down. And we know this logically. If we climb, that we could fall, but you're not going to just be standing and then just fall for no reason.
But what's the force that pulls you down? Like
there is no force that pulls you down.
Well,
there's buoyancy and density, and there's up and there's down, but there's not when you're standing, like I'm sitting on this chair right now, there's not a force that's pulling me down.
But like, if you were gonna jump off the Empire State Building, you would go splat. So,
well, yeah, you're heavier. Yeah, you're heavier than air, and you're more dense. You're going to go down, and you're going to fall. But you know that. But you're not going to like stand, and I'm not going to just float away. It's just it's really basically common sense. But when you believe the heliocentric theory, you get caught up in that because you need gravity to explain how we could be like, spinning and hurtling through space at such astronomical speeds.
Right. So then what causes weights then? What's the effect of weight?
Well, I believe that something that's more dense has more weight to it and is heavier, and it's just basically that simple.
But what is weight?
I would assume it's density of the object.
Excuse me. I've heard some model of the flat Earth. They say the flat plane Earth is accelerating through space, and that is what causes it. Do you buy into that at all, or is yours a different model?
No, I think that's completely inaccurate and just absolutely silly.
No.
Yeah, I don't
Okay.
even know where. I've tried to figure out where they got that from, what they based that whole thought process on, and I've never been able to find anything logical to that at all.
Well, I haven't either. What's keeping all of this stuff on the Earth? If there is in fact an edge, right? What keeps the atmosphere from kind of flowing off and into space?
Oh, okay. Well, that's another great question. You've got to understand what space is, and I'm not going to delve into that at all. But there's no edge that anybody's going to fall off of. There's no edge that the waters are going to fall off of. That's just silliness. Okay? The flat Earth it is inside a perhaps infinite plane. Okay, Earth is inscribed inside a perhaps infinite plane. Okay, and so there are no edges that the waters are going to fall off of because it's sort of encompassed and surrounded. Basically, we believe that it's surrounded by ice.
By ice. Okay. So
Yes.
in that case, then, if there is in fact an ice wall, do you think it's what's keeping people from going to the ice wall and just finding out?
And finding out. Well, I think people have been to the ice wall. There's lots of photographs of it. It's the southern. Whenever you go south, whenever you venture south, you go south long enough, you're going to end up at the Antarctic Circle. And we believe that the Antarctic Circle is the ice wall that completely surrounds the Earth and holds the rivers in, the waters in, I mean. So, and it's there to be seen. There's not, you and I can't go journey there because of the Antarctic Treaty. I'm sure you've heard about that. But hopefully that one day that'll be changed so that we can all go there and check it out.
Well, there actually are tour groups that can go to Antarctica.
Mm-hmm. Yeah.
So, but are you just saying that you just can't go past a certain point where, if they go past this certain point, then they'll see the ice wall and that'll be it? Okay. Well, do you think anyone's been to the South Pole?
I think no. I don't believe that there is a South Pole. I think that I believe that if you went to the Antarctic, you would have to go extremely far into the Antarctic Circle before you would ever even get even close to discerning that it was just an ice wall. The entire thing is an ice wall holding the waters in. I think you could journey on and on and on and on, and for a great distance before you would even find that out. Yeah.
Okay. Well, keeping on the topic of Antarctica, because I guess that's kind of the that's a point where there's a serious disagreement between the flat earthers and the round earthers. Just with the round earth model, how the round earth model is, the Antarctic is the bottom of the globe, and it's if you looked at it from the bottom, it's a circle, right?
Mm-hmm.
That has a certain circumference, right? The circle itself has a certain circumference.
Yes. Allegedly, yes, it would have to if it's a continent.
Right. Now, according to the flat Earth model, it's not. The Antarctic is the outside. So
that's right.
It would be a completely different circumference, wouldn't it?
Mm-hmm. Oh yeah. It's not a continent. It's completely surrounding the Earth.
Right, but and do you accept I'm sure you've heard of the Flat Earth Society and their map. Is that kind of your opinion of what the world looks like?
The Flat Earth Society is not necessarily a good source of information. I don't really know exactly what their deal is, but they have a lot of misleading information on their website. So I'm not sure exactly what you're referring to, but there is that general basic model of the flat Earth that we see online, and I think that's a fair generalization. We don't know the shape of the Earth. We're not even trying to say that we know the shape of the Earth. We're just saying that we're not a spinning sphere hurtling through space.
Okay. So do you know the United Nations symbol?
Yes.
Is that what you ascribe to?
It looks an awful lot like what we consider the flat Earth with the Antarctic ice ring around it. So yes.
Yeah. So that's what I'm talking about. The circle on the outside.
Right.
There would have to be a certain circumference to that circle, right? And it would be much, much different from the round Earth kind of Antarctic circle, wouldn't it?
Yeah, it would have to be.
In terms of
I
diameter
think
and radius.
it's right. Oh, absolutely. Yeah. Like I said, I believe that it's perhaps infinite, as the same as, the heliocentric model says the universe and space is perhaps infinite. I do believe that the plane that we are in goes on infinitely. So, and that's not something that we can even really conceive of mentally.
Right. Yeah. But we'll get to the kind of the difference between the second dimension and the third dimension, because that would be another point of dialogue there. But saying is the diameter, or not the diameter, the circumference of the Antarctic, according to the United Nations layout, the map, would be much bigger than the circumference of the Antarctic circle as we know it, according to the round Earth model. And do you accept that? It would be much, much different.
Yeah, I don't think that the representation that we're told is even remotely close to what's really, accurate of the Antarctica. I don't think the information we're given about it has hardly any basis in reality. I mean, if you look at Google Earth, you can look at the Antarctic on Google Earth and you can see where it's like pieced together if you zoom in. And I know that they have to do that in certain areas, and that I understand that the satellites take pictures and photographs at different times of the year. I understand that, but it's if you look at it, it's obviously pieced together. It's not the rest of the Earth looks is totally different from the way they've got Google Earth on the Antarctic all pieced together.
Okay. Do you think that we can test to look at the circumference of Antarctica? Because we both agree that Antarctica exists, right? Do you think it's possible to test the circumference?
Well, no, actually, I don't think so, because, like I said, I think it goes on infinitely, possibly. So the Antarctic goes on to something that's part of an infinite plane. So I don't know that we could even conceive of how large it possibly may be. And plus it surrounds the Earth, so it would be massively huge.
Okay, well, I'm not talking about Antarctica. I'm talking about kind of the inside border, according to the.
Okay, I got you.
That
right.
part.
Okay, I follow you. I got you. Yeah.
Yeah, that part. So that would be a lot different. You know what I'm saying? And do you think we can test? Do you think we can test to see what that circumference is?
Yes, absolutely.
And you think that it would be much, much bigger than what scientists currently acknowledge as the circumference for Antarctica?
I do, yes.
Okay. See, that's the point where we can go out and we can test that,
That's right. Absolutely.
Right. So, yeah.
Yeah, absolutely.
So, yeah, maybe we should do that.
Yeah, and that could just end it all right there. There'd be no question.
It would. Yeah. So
absolutely. And the people that have done that, the people that have gone to like sail all around the southern continent, have journeyed for extreme long periods of time. The few people that have actually done it and been able to go the distance have traveled for a very long period of time. Of course, I know there's probably some false information out there too, but nobody's actually like circumnavigated over the the southern pole.
Right. Well, people have been, according to some people, they have actually been to the South Pole. As far as I understand, no one's been across the entire Antarctica.
Right.
But so you think the people who claim to have been to the South Pole are either incorrect or outright lying?
I really don't get into calling people liars, because I don't think that I don't think there's a whole bunch of people like, conspiring and lying about this. I think that, humanity has made some very serious mistakes in their assumptions and whatnot, but I wouldn't say that they're lying. I'm sure that they really thought that they had reached the South Pole. I mean, we're talking about an inconceivable mass. So
Do you think that there are people that have actually claimed to do experiments on the South Pole? You think,
yeah, they have scientists there, certainly.
but are they? So you just think they're wrong?
They're there. They're at the Antarctic. What I'm saying is that the Antarctic is just far more tremendous than what we've been told, and they're only on the outskirts of it. People are not allowed, or what people that at least people that are not everyday people are not allowed to go on to the. You have to be there for the basis of science. You have to be perhaps military. Those people that are able to go there for vacation or whatever are not really being allowed very much access at all.
Right. Yes, I understand that. But
nor the time that it would take.
Right. So, well, I guess we can talk about the South Pole a little bit. Are you aware of the Foucault pendulum?
That's one I've not read too much about. I'm not sure what it is that you want to say about the pendulum.
Okay. Well, essentially, what it is it's a pendulum, and it was first kind of created in 1851. And my understanding of it is it demonstrates the Coriolis effect, which is
okay.
Yeah, and I would assume that you disagree with the Coriolis effect, don't you?
Yeah, that's really just a myth. They say that like toilets, the different toilets can spin different directions here in the United States. The same anywhere. Yeah, that's just that's not even. It's just not even true.
Okay, well, before
you can see this for yourself. Yeah.
How would I see this for myself?
Well, there's different makes of toilets. I hate to be talking about toilets, but different makes, they'll spin one direction, and other makes will spin a different direction. So it's not it's not true.
But do you accept the idea that all motion is relative?
I don't know about that. I'm not too sure. So
Do you accept? There are Canadian snipers and American snipers, and when they have to lead their target according to the Coriolis effect, do you believe them?
I'm not familiar with that. I couldn't actually make any statement about that. But like I said, I don't think that people are lying. I think people are just misguided.
So the people who are sniping,
I don't know anything about that. Could you explain that to me? What do you mean they're sniping and
Sure.
they have to leave their prey because of the Coriolis effect? I don't understand that. I'm sorry.
The Coriolis effect is it's the effect. It's kind of hard to explain. It's the rotation of the Earth, and it's when snipers are sniping their target, they have to account for the Coriolis effect. So that's what they do. They lead their bullet a certain distance to counterbalance the Coriolis effect. Or at least this is what military sources and snipers from across the world say. They have to do this. And all it really is just accounting for the rotation of the Earth, according to them. There are interviews of this. Do you believe them?
I find that very unlikely. I'm not saying that people aren't trying to account for that when they're shooting. I love to shoot, not animals. I don't kill anything, but I love to shoot. And of course, I'm talking about target shooting, and I've never had to account for the rotation of the Earth or anything. But maybe I'm not shooting far enough.
So in order for the Coriolis effect to really take effect, it has to be a pretty long distance. According the longest sniper shot that's ever happened, they had to account for the Coriolis effect.
Well, okay, that's fine. If you want to say that, that's not really given too much of a basis for, I mean, for me to believe that the Earth is a spinning sphere, is that there's might be some snipers out there accounting for the Coriolis effect. You've got so much other things you have to take in effect when you're shooting. You've got, the wind, you've got trajectory to consider, other than the Coriolis effect. That would be probably, I've never actually heard of anybody having to account for that when they're shooting, except for like a movie I saw once.
Okay.
Yeah.
So,
yeah.
Of course, the way experiments normally work is you try and isolate certain forces and certain factors, right? So going back to the Foucault pendulum, what it is it's a pendulum. And you know how a pendulum swings back and forth? Well, essentially what happens is a standard pendulum. It's hung high, and the axis of the swing, it rotates according to the rotation of the Earth.
How do you know it's the rotation of the Earth? I'm not seeing the correlation there.
So the correlation is you prove the causation by eliminating every single other factor. And we've done this many times. What we're able to do is we're actually able to come up with an equation, the latitude to of this pendulum. I know it's a little bit complicated, but there is an equation out there that is able to predict where you are on the Earth based on the period of rotation of this particular pendulum. Do you understand what I'm saying? Or is it kind of, it is kind of difficult to explain these mathematical concepts?
It's understand. Yeah, I'm following you. That's not difficult at all. I got you.
But what you said about the toilets earlier, where you have some that rotate clockwise and others that rotate counterclockwise.
Right.
You can, I'm sorry, just 1 minute. As I was saying, this is how we isolate that particular factor. So the rotation is, in fact, opposite depending on where you are in the north or the south.
Well, I just disagree. I don't agree with the pendulum being proof of that the Earth is rotating. So there's more motions than just the Earth's rotation. That's not all the Earth is doing. There's many motions that are part of the heliocentric model, not just rotating Earth.
Okay, could you name one?
Yeah, the Earth, while it's rotating about, I don't know, over 1,040 miles per hour, it's also going around the sun about, I don't know, approximately 66,000 miles per hour, and then the entire galaxy is allegedly hurtling through space up in the, like, I don't know, 600, thousand or million miles per hour. It just starts getting more and more insane, and all these motions are going on at the same time. So why is your pendulum only accounting for the motion of the alleged rotation of the Earth?
Because motion is relative, and the effect of the galaxy moving through the universe wouldn't have an effect on this.
Why not? How could that possibly be?
Because this is an isolated system. I mean, of course, the Earth moving around the sun is going to have somewhat of an effect, but it doesn't really have an effect on the pendulum itself. And the equation we're able to come up with, which I have right here in front of me, it works regardless of where
Okay,
you
well
are on
then
the
how,
Earth.
if the motion of the Earth allegedly circling around the sun at about 66,000 miles per hour, and you're saying that doesn't affect the pendulum in relation to the rotation, alleged rotation of the Earth of about 1,040 miles per hour, how can you back that up with what you're saying?
So
Not relative doesn't explain. You're not making a strong case here for what you're saying.
so okay, so what you're saying is, I guess the rotation of the Earth, the Coriolis effect, it is an effect, but you have to take into account other factors like wind resistance, for example. That's why when I jump, it's not like I go flying. You know what I'm saying? There are other forces that are in play. The Coriolis effect, it's very minor, and that's why you can't just jump up in the middle of space and go flying. And that's the same kind of reasoning that we use to justify, all sorts of
Well, I believe
motions.
allegedly, if you were in space, allegedly you could jump up into space and go flying.
Right. Yes, that's in space. On Earth, there are other forces that it's not a vacuum. You understand what I'm saying?
Well, and space is not a vacuum either. But no, the Earth certainly is not a vacuum.
Right, but it's not a total vacuum.
Uh,
But the universe, the outer space, is a lot more like a vacuum than here within the atmosphere. Correct?
No, I totally disagree with you. But I'm not going to discuss what about space, because that's on a totally different level, and most people can't really can't handle that concept. So I don't really go there. But I'm just asking you. You're saying the pendulum, and you're using that as a basis with some mathematical equations as evidence for the rotation of the Earth, and I hear what you're saying. What I'm saying is you can't just discount the other motions that the Earth is making.
Right. But what I'm trying to tell you is there are reasons why when we jump up, we don't go flying. The rotation.
Well, I don't think that when we jump up, I wouldn't think that we would go flying when we jump up. That would be ludicrous.
Because there are other forces that are affecting that. The Coriolis effect can be isolated, and we can look at that independently, and that's the purpose of the Foucault pendulum.
But now, are you saying that the Coriolis effect has something to do with the forces that the alleged forces that when you jump up and that you don't go floating away or something? I don't see what you're saying.
No, what I'm saying is the Coriolis effect is, as far as we know, constant. But the reason why when we jump up in the middle of the air here on Earth, and we don't go flying, is because of other factors, like wind resistance, for example.
You mean other factors besides the Coriolis effect? Is that what you're saying?
Yeah, the only reason why this pendulum works is it's a way we can isolate the Coriolis effect and test it independently.
You're not isolating the Coriolis effect with the pendulum. Okay, the motions that the Earth is allegedly engaged in are not being isolated with a pendulum.
Well, we can test it on different parts of the Earth, and the equation remains the same.
Well, you can write mathematical equations for anything and everything that'll work. It's a quantitative, language, and I don't really see what you're trying to quantify with a pendulum and the Coriolis effect, quite frankly. But anyway, you've not indicated to me in any way how you're isolating only the Coriolis effect. So basically just the rotation of the Earth, and not accounting for the other alleged motions that the planet supposedly is in the heliocentric model being engaged in.
Okay, well, when I say I'm isolating the Coriolis effect, I mean I'm taking out other factors like wind resistance, other things like that would be in the experiment.
Yeah, and wind resistance probably, when you're talking about the alleged Earth spinning around the sun and hurtling through space, I doubt that wind resistance here on Earth would really play much of a factor into that.
Okay. Well, I mean, yeah, go ahead, Badger.
I'm curious as to how did the behavior of the sun and the moon fit into the model that you adhered to?
The sun and the moon?
Yeah.
They are luminaries. Yeah, they're luminaries, and they are rotating above us.
Right.
They are rotating around the Earth above us, and they're a lot smaller. They're
What is keeping them above Earth if everything else seems to be going towards Earth?
I think that it's very possibly an electromagnetic force between the Earth and the luminaries, the sun, the moon, the stars, and the wandering stars, the so-called planets, are all interacting together, sort of like a like a Tesla ball with the energies and stuff, the electricity. That's what I suspect, but I don't,
Could you
it's
give
just
me
a theory.
Let me know what's a luminary? What's it made out of?
Well, I don't know what it's made out of, but I would guess that it is, I think it is an electrical force within a type of, I'm trying to think of what the word I was trying to think of. What I'm thinking, trying to say.
So you don't accept that it's made up of
some type of
primarily hydrogen, helium, and other metals?
Think that it's electrical forces in a form of H2O light up in the
Water?
in the firmament. A form of, not exact specifically water, but I do believe that it is in a different form. Yes. Yeah, it was saline.
Okay.
Salt.
Do you know
That's exactly what I'm saying?
Do you know the chemical composition of this kind of water?
No, that's what I was telling you. H2O, salt water, basically, very basic salt water.
Okay, and sorry, go ahead, Panda.
No, you go ahead.
I need to account for, well, the days and the nights. If the sun is directly above Earth, shouldn't the entire plane of the flat Earth be illuminated constantly in day?
No. The sun is definitely large, but it's not as large as, it's not as huge as we've been told. But the Earth is tremendous, and we have a local smaller sun that is part of the time over about half of the Earth, and it's circling around above us. And as for the months, it moves like more, it'll go more southern and on a path, and it'll go more northern on its path to parts of the year, and that accounts for the different seasons and whatnot. And as well as the moon and the sun, I believe, are about the same size. They're not. Yeah, the sun is not 93 million miles away. It's much, much closer.
How big is the moon? How big are the moon and the sun? Do you know how big they are?
I don't know how big they are.
Okay.
Surely if we would be able to see the sun 100% of the time, correct?
No, not at all. The sun is a lot smaller. We've been told that it's this huge, tremendous ball of fire. It's not a ball of fire. It's just a luminary, and it's a lot smaller, and it's just circling. And the Earth is huge. It's just circling, so it's only able to illuminate approximately half of the Earth at a time.
Okay, I have a question though. So I guess this is kind of like a spotlight, and it's kind of traveling around the world in that way.
Sort of.
Okay.
Mm-hmm. You could say that, yeah.
So, well, I think what Badger is saying is, if let's just say you're in Argentina, and it's day over in Australia, you should still be able to, if the Earth is flat, you should be able to see the luminary.
Well, see, now we've been told that light travels infinitely, and that's not true. Light only travels so far. It doesn't travel on and on for thousands of light years. That's not true.
Where does the light that's reflected from the moon come from?
I don't know exactly if it's reflected light. It may be reflected light. I'm not too sure if it's light that's reflecting, say the sun is, you know, reflecting light on the earth onto the moon. But most people tend to say in the flat earth model that they believe that the moon is itself its own luminary and has its own light that it's emanating, that it's not actually reflecting light, that it actually is a light itself.
So how do you account for other stars? If we're unable to see the sun, then because of its distance away from us, how can you account for the observations of stars
Why
much further
wouldn't we
away?
be able to see them? Well, I mean, when the sun moves out of you know, our area and it becomes nighttime, then we can see the sun. I mean, the stars. Be able to see them. Maybe I'm not understanding what you're asking.
Oh well, the sun and the stars are the same thing, are they not? Are they luminaries?
They're all luminaries. Yeah, they're all luminaries.
Right. So if you can't see the sun, even though you can look in the direction of where the sun actually is, how come you can see the stars that are further away?
Well, you can't. The sun and the moon and the stars are all moving. They're moving around above us, following the exact same paths that they have for thousands of years. This is documented, and that would be completely impossible if the Earth was a spinning sphere hurtling through space. I mean, that's.
Well, actually, I like you. So there are different constellations you can see depending on where you are on the Earth, right?
Absolutely.
So
Yes, absolutely.
If the Earth is flat, right?
Mm-hmm.
Are we not just looking at the same image of the sky? Is it not changing? Okay, can you explain that?
It changes. It changes. If there's stars that you see more predominantly in the northern areas, and then there's stars that you see more predominantly in the southern areas. And when you're in between the northern and southern areas, you can see more variation of the stars. But the stars are fixed as they go in their fixed paths around the Earth. Okay, and the stars, I'm sure that where the sun, I don't know this for a fact, I'm just saying, I'm gonna make an assumption that where the sun, when the sun is above us, there are probably a bunch of stars that we just can't see because of the sun, okay? But as the sun travels its path and the sun and the other stars are traveling, they're not the sun and the stars, I'm not saying they're the same thing, I'm saying the stars are also luminaries, but the sun is a very unique, specific, you know, luminary of its own. It's a very grand luminary. But you've got to understand how huge the Earth is, and you've also got to understand that it's not true that light just travels indefinitely. It doesn't. It's very limited.
Okay. I'll make a few questions as an offshoot of that. So what you're saying is the constellations, they change as
they don't change.
They don't change at all?
Our perspective, no, they don't change. They follow their exact paths. They do not change. Now, the wandering stars move, but they also move in predicted paths, the so-called planets. But no, I'm saying depending on where you are on the Earth, you may see different constellations, is what I meant.
Right. And I would agree with that.
Yeah.
But so how do they exit our view?
Perspective. We cannot see indefinitely. And even with telescopes and cameras, yes, they can further our vision. We still cannot see indefinitely. Like supposedly the Hubble telescope is taking pictures of billions of years, light years into the past. That's a bunch of BS. That's not true. We cannot see indefinitely, nor do we have any telescopes or any kind of objects that can see indefinitely. We have perspective and it's limited sight distance that we can see. That's logical.
How limited is that view? Or how limited is our perspective or our sight?
Well, I don't have the mathematics on that exactly, but you could probably figure that out with the telescope. Our zoom lens that I've got a Nikon P900 that can see, it's got the distance that I can focus on, so I can get an idea of the distance that I'm seeing, but I can't like offhand right now quote that to you. But no,
Sure.
We're not seeing billions of light years into the past. That's not true. Light does not go on forever. It diminishes.
Okay. So does it diminish? How does it diminish? Does it get weaker and weaker as it goes on, or does it just kind of like just
gets
does it
weaker
just
and weaker,
disappear?
and then it's done. You know, I probably couldn't get any more specific than that. If you have a light source, it's emitting light. If that light source is turned off, then that light is just gone. It's not going to, that light is not going to just keep on traveling. It can only travel so far depending on the size of the light source.
So
There's
this
my chihuahua.
the speed and I guess we could say endurance of the light depends on how big the light source is.
No, I didn't say that at all. No, I
What'd you
just said
say?
that. I just said depending on the source. I mean the source of the light and how huge it is, the magnitude of it. I'm not saying that that light is going to continue on any further. I just mean that when that is illuminating, it may be illuminating further. As soon as that light is turned off, it's gone.
As soon as it's turned off, it's gone. So
Gone.
so it does fade. It just fades.
Yeah, you could say it fades.
Okay.
But like if I turn this light off, the light that it was making just is gone. It's not,
Right.
the light's not going to, it's not going to continue to travel on and just keep going off like, you know, like that with the Hubble telescope. Anyway, it's just silliness. If you just logically think about it, it just doesn't make sense.
Okay. Well, we can move away from the topic of light. There's actually some disagreement within the flat Earth community as to what shape the other planets are. Are they flat or are they round like this one?
Flat, they're circular and they're flat. There's different shapes though. I actually, well, there's one star that I photographed and, well, it actually looked more like a polygon, but most of them all look round, circular, not spherical, but circular, and they're flat. They're just luminaries, they're just lights. They're not bodies of mass that you can land on. They're not rocks out floating in space.
So they're just like
They're just lights.
they're just lights.
It's just electrical source emitting light. They're just luminaries.
How do you account for radiation being emitted from the sun?
Well, it doesn't discount radiation. I mean, you know, radiation can come from light and from, you know, different electrical sources. So that doesn't, it's not discounting that anything's emanating radiation. You know, light is a type of radiation, I believe.
A part of the electromagnetic spectrum, the visible light, yes.
Right. When?
Not about neutrinos or anything like that. Oh, like the physics model. What does that to account for to your sun?
I'm not going to say that I have all this mass knowledge of the sun or that study. I'm doing some photography and I'm doing some observations of the sun, but I'm not, you know, I've been studying a lot of physics and basically trying to find, you know, full of, you know, assumptions that have basis of no basis in reality. So, but I'm not being in and of my own self making statements that I've studied the source of light emanating from the sun and the qualities of it.
Sure. Panda?
All right. I guess that's pretty much all I wanted to ask you about the planets. So you just think they're luminary sources and nothing else?
Right. Exactly.
Okay. Let's just say what this is what's really confusing me. This is like the most confusing part about the whole flat Earth model to me personally. How exactly do you account for solar and lunar eclipses? How does that work?
Well, actually, since we just had a solar eclipse, and I live in, right now I'm living in Indiana, so I got a pretty good view of it. Unfortunately, I didn't get to see totality. I was a little disappointed, but basically from what my photographs and the videos, I used a few cameras, and it was almost like, okay, I did not see any indication of the moon moving in the path of the sun. There was absolutely no indication. The moon was not visible. It was almost as if the sun itself, if there was maybe a translucent body that went in front of it or something that you just, you know, that hindered the light a little bit. I don't know. Some people have theorized about that. And others have said they didn't see anything that went in front of the sun. So I don't know if the sun's just going through some sort of discharge of its light. I honestly don't know. You know, it's the moon goes through different phases throughout the month, and I don't know, maybe the sun just did a quick phase there. Maybe it was just doing a quick phase of the sun, and we just don't understand these things.
What about a lunar eclipse? Is it just
A
another
lunar
phase?
eclipse, I've not studied a lunar eclipse, so I don't try not to speak on things that I don't know about. I've not studied a lunar eclipse. I've not seen a lunar eclipse, so I can't say.
Okay. Well, I'll just explain it really quick. The difference between a solar and a lunar eclipse. A solar eclipse is when the moon eclipses the sun. So the moon covers up the sun. And a lunar eclipse is when I believe the Earth is in between the sun and the moon, so the moon is not visible.
Right now, and I do understand that. I do understand the common knowledge that we are all taught. I realize that.
Okay. So, but you just disagree.
I wasn't discounting the fact that maybe the moon did go in front of the sun during a solar eclipse. I was completely open to that. I'm just saying that from the photographs and from the video and from not just mine, but everybody else's, there was no indication at all that the moon went in front of the sun. But no, I wasn't discounting that that was possible. That's what I was looking for. And I saw no indication of it.
So under your model, though, isn't it practically impossible for the moon to cross in front of the sun or vice versa without there being
Not at all. Without there being a what?
Without there being some sort of shift in the day-night cycle?
No, no, it wouldn't. No, with the flat Earth model, you could have what they could cross paths. That's not out of reach at all.
So, but how would that happen? Because in order for that to happen, the day-night cycle would be completely. It would imply that the sun and the moon are not. They're moving at different speeds.
Mm-hmm. We all have seen the moon during the day. Okay.
But
the moon moves. The moon is moving. It's got its own paths that it's taken, and the sun's got its path. Okay, and they are different vicinities of each other throughout the year. Not unfathomable that either one of them could cross in front of the other's paths. Okay, I just obviously I don't believe that it happens according to the heliocentric model, and I was looking for evidence of that. I became a flat earther by trying to prove the heliocentric model to be valid and accurate to myself, and it failed miserably.
Okay.
So, but I'm still open to any type of evidence for it. That's what I was looking for with the solar eclipse, and it just failed miserably.
Doesn't it kind of convince you that NASA at least has a little bit of credibility, because they predicted this a long time ago, didn't they?
Okay, now people, our culture and society has for a very brief period of time believed a spinning sphere. Okay, no matter what you think you've been told, you can do some research on this. The ancient people, and these were not ignorant people. These people were able to do things that we to this day we cannot duplicate. Okay, like the Egyptians. You can look all this up. Okay, and they have been predicting eclipses for thousands of years accurately. Not NASA. Okay, and all that is based on fixed stars, the sun, the moon follow repeatedly. Okay, that's how they're able to predict that. If the Earth is a spinning sphere, rotating while it's hurtling through space, hurtling around the sun, there's no way in heck that it would be able to maintain exact paths of the stars rotating around us, because it would be impossible, and that's illogical. If you just think about it a little bit, it just makes sense. Okay, there's no way, and there's no way that the heliocentric model could predict a solar eclipse or predict any astronomical anything that was going on at all, because it's not possible that the stars, the sun, and the moon would be following the exact paths that they do year after year after year after year for thousands of years. Has been documented that it only works if the Earth is flat and stationary, and the sun, moon, and stars are rotating above us as it appears. and as
Okay.
the ancients have always believed.
Okay. Well, this is another example of something that we can go out and we can test. So we can make perhaps a prediction of when the next solar or lunar eclipse might be.
Yeah, and they
And
already
this
have.
is right, and this is how we
Yeah,
test models.
this is the star chart. All that is based on the star charts and also on the thousands of years of documented paths and movements, the sun and the moon. Okay, that's what all this is based on, and the wandering stars, the so-called planets. Okay, that's what all that information is based on. It's not based on the Earth rotating and spinning and hurtling, because it wouldn't work.
So the flat Earth
It's not
model.
possible. Now, please answer me this. I mean, how could you possibly have all of the stars following the exact same paths? You know, you can look at the time-lapse photography of the stars, and you see they're following the same paths, and that's how we're able to predict eclipses, etc. How could you explain that if the Earth is spinning and rotating and hurtling and going around the sun and hurtling through space 660,000 miles per hour? How can you explain that? How could that even be possible?
Well, my understanding is the rate is constant enough that we can derive certain equations and algorithms to make this stuff work.
Excuse me? No. The rates of what? What are you talking about?
Well, for example, oceans you've described, we can build equations based off of those. That's how
You
this
can
stuff
build
works.
equations. Yeah, I studied mathematics in college. You can build equations off of anything and everything you want. That's perfectly fine. That I'm talking about the stars, the sun and the moon, follow exact paths that has been documented for thousands of years. Okay, how is
Right.
that possible that they could follow the exact same paths repeatedly over and over and over again if the Earth is rotating 1,000 miles per hour and is going around the sun 66,000 miles per hour and hurtling through space, the entire galaxy, 660,000 miles per hour? How could those stars exact same paths around us?
Well, because for the most part, everything is constant, and we can, again, it's all about predictions. I don't really see a contradiction here.
You don't see a contradiction here. There's no way that the heliocentric model can predict any of that. You have to go by the okay. Some people are not able to see. They're just not able to see the truth. I mean, when I got introduced to it, even though it wasn't that long ago, and I believed exactly as you do, very much the same as you did, but when some logical and some inconsistencies were presented to me, it got me to think and to question, and I studied and read into and looked into this and started to see the assumptions and the things that don't make sense. It's not logical to think that you can have the stars they're rotating around us, following the exact same paths, and how you think that the stars that are allegedly, even according to your model, millions or trillions of miles away, and they're following the exact same paths, but yet we're rotating 1,040 miles per hour. They're spinning around, and then we're going around the sun. And how on earth could the stars be following the exact same paths, being millions and trillions of miles away from us? That is completely illogical and completely does not go. It goes completely against itself.
Do you think that you might be able to predict the flat Earth model? Do you think it might be able to predict when the next solar or lunar eclipse might happen, or is that mathematically impossible?
It is the flat Earth model that's predicting that. It is all of the information that from these cultures that go back to the ancient cultures, thousands of years documenting the transits, the paths of the stars, the sun, where the predictions model from which they come.
I'm sorry, I just missed that last part. There was a break in my connection. Can you repeat that?
It is a flat Earth model from which these predictions come from.
Okay. I really don't have very many other questions. I think it's really mostly about, for me, it's about making predictions and then seeing whether they come true.
And the
Right.
predictions that you make are from is from the flat Earth model. There's not, those predictions are not from the heliocentric model. If you study the heliocentric model in depth on your own, take the time to actually study it, go back, research the early astronomers. I don't understand why you think that these predictions are coming from the heliocentric model.
Well,
It's not
NASA
even
believes
possible.
NASA believes in the heliocentric
No,
model.
NASA knows exactly what's going on, or else they would not be able to predict the eclipses. Okay. I mean, where are you getting this from? Just because you read this online or something? I mean, look into this yourself and see if you can predict yourself with the star charts. Okay. And what's been documented for thousands of years, that's where the predictions come from. How do you think NASA's making these predictions?
I have a link.
With mathematical equations of algorithms?
No. I have
They're
a link.
making these they're making the predictions from the documentation that has been made over thousands of years of the predicted paths of the sun, the moon, and the stars. That's where the predictions are coming from. They're not coming from mathematical and algorithms. What has already been documented and predicted.
So that would be something that I would have to check on my own time. But
Dude, that would be awesome. That'd be awesome.
Yeah.
And
I
your
don't have time
questions
to do that on
your
stream.
questions have been excellent. Yeah, you've had excellent questions, very good questions. And I wish I could have answered them better. I did the best I could, and I do appreciate your questions and your thought into this, and very enlightening.
All right, Badger, did you have like people on the chat that wanted to ask questions?
There are quite many. I'll just read one out now. You've got,
Yeah.
Gonna go for it. Distance between South Africa and Australia on a flat Earth model is greater than the range of a 747. How can Qantas make that a direct flight without mid-air refueling?
Okay, that sounds like that might be coming from a flat earther.
No, I'm pretty sure he's not a flat earther. I know him on Twitter.
Okay, well okay, I see. So you're saying that the distance, now the flat Earth, we are not saying that we have an accurate map, though all maps are flat. They're all flat. That we have a map specifically that has all the accurate distances and the accurate sizes of the continents. And I would say that the maps that we do have are not, they are not exact representations of the accurate sizes of the continents. I mean, we know that they have some countries larger than others, and some are not even in the appropriate places where they should be. Our maps are not perfectly accurate. They are a bit misleading.
Okay, but and this comes back to my point that I made towards the beginning, is that this can be shown through mathematical equations, correct? We can test this.
Now, I'm just kind of curious. I mean, your questions are great, and they seem rather far-reaching. There's very simple things that prove to you that the Earth is flat, like the properties of water. To believe that the Earth is a spinning sphere, you have to defy the properties of water. You guys seem to be like kind of jumping beyond all of the common sense logic for these kind of like, well, maybe the Coriolis effect that I told you doesn't even exist.
Why?
Okay?
What are the properties of water?
Water is that it always flows to maintain its level, and that it forms to its containment. It never, ever do we see in nature where water conforms to the outside of its containment. That's impossible and ludicrous and never happens.
Are you saying that the water has been held in place? Because, gravity will pull from the core. That's why the water doesn't fall off.
I'm saying that that wouldn't even work, for one thing, if that were true, but it's not. The waters are contained, but they are not being contained by gravity. They're not free flowing. So you're saying that water has to curve, and water does not curve. Okay, it does not curve. The water is not curving around a sphere. Water maintains its level and is flat. 71% of the Earth is water, so at least 71% of the Earth is flat. Why do you think the remaining percentage is a sphere?
What do you mean by
stuck to it?
So what do you mean by curve? Because if the gravity is pulling to the core from the center.
No, you're not. No, don't be thinking about that. Think about water. Think about water. What does water do? Water maintains its level. Water is flat.
Yes, because
Any instance of water curving. Water does not curve. It's not possible to water curve. It holds its containment. Up and curl. It doesn't flow upstream like it would have to if the Earth was a spinning sphere. Water doesn't flow upstream. That's not true. Okay, and it doesn't curve around anything.
Why would it flow
flat.
upstream?
Water is flat. Earth is a globe. There's areas where it would have to, because allegedly there's no up and there's no down. Okay, and there are times when water in different parts of the world, if the Earth is a spinning sphere, that water would have to, by definition of a globe, water would have to be flowing upstream, and we never see that. That's impossible. That never happens.
Why?
Water is flat. 71% of the Earth is flat water. Why do you think the rest is somehow round into a sphere?
Why would you think water would flow upstream?
It doesn't.
Yes, I know, but why even mention?
It doesn't flow upstream. You don't. You're showing that you don't know your own model, because according to the heliocentric model, yes, it does flow upstream, and no, it doesn't. Study the model that you're defending. Okay, I have.
No, I'm still not understanding this. Water doesn't curve. I mean, it works in the
Water does not
gravitational
curve
model.
around. Water does not. Okay. You, according to the heliocentric model, you have a sphere, and according to the heliocentric model, water is curving around this ball and is a sphere. The 71% of the Earth is water, okay? And if the Earth is a sphere, then 71% of that sphere is water that's being held together allegedly by gravity. So water would be curving, and we know that's not true. Water is always flat. 71% of the Earth is water, and it's flat. So you know at least 71% of it's flat for sure. Why do you think the rest of it would be a sphere? Water being curved around it, and that's impossible. It's just illogical. Just think. All you have to do is think.
I mean, there are many.
Yourself.
For me, that it fails straight off with the sun and the moon, because you say light fades away as it travels a distance, but we cannot see the sun directly. However, the light's still maintaining somehow to reflect
The sun directly.
moon.
What do you mean you can't? You see the sun directly. It's right there over you during the day. You see it directly. How are you saying you don't see it directly? As it moves away, then it becomes nighttime. This is very logical. Why do you think the sun would just be?
Because what we're saying, if
you guys have to think. You've got to stop believing everything you read, and you've got to think about what you're saying and the logic or lack thereof of what you're saying and what you're believing. Use your brain and think for yourselves. Don't believe everything that you read.
Right, if the sun is moving away from you so far enough so that you can't see it anymore, how can we see the light that has come past us and now reflecting from the moon?
I didn't say that you could.
But we can see the moon.
I said that the moon was probably its own self-illuminator. A lot of people in the flat Earth model, the flat Earth community, believe that the moon is emanating its own light, that it's its own luminary. They talk about how shade is, like the moonlight is cooler than shade type of light, and that it's a luminary in and of itself.
Right, so this is what I mean. When it comes to the point where the flat Earth model fails, I mean, we have plenty of evidence to suggest the chemical composition of the material of the moon, and it does not emit light. I mean, where's the observations that you have to say that the
That's
moon
not true.
does
You're believing that the moon is nobody's landed on the moon. If you're believing that people landed on the moon 50 years ago, why haven't they been back? NASA says that they don't have the technology today to land on the moon. They cannot land on the moon today. Why do you think they were able to do it with the technology we had 50 years ago? You've got to kind of grow up and deal with reality. I mean, it's sad but true that everything that we have believed all these years is a bunch of lies. Okay, it's time to wake up, open your eyes, and deal with reality, because it's beautiful.
And where are the observations or tests for the composition of your suns with the electrical
composition of the sun?
Yeah, how does the electricity work? How does it form?
You could read Tesla to study that, and there is actually they've done some. I'll tell you what. I'll send you some links to some stuff, but I'm not going to talk about that myself and say that I've not done any research on this myself. Okay, but I might ask you is, I mean, how do you think that we possibly know the composition of the sun?
It's called spectrometry. You can, if you look on the electromagnetic spectrum on the visible light, if you
And
look
that's
close
giving
enough,
you that's giving you and what's composite, and what is it saying the composition of the sun is?
well, if you look close enough at the visible light, you know, where you have red all the way to
What is it?
blue.
What does it say the composition of the sun is? You just said that it gives the composition of the sun. What does it say the sun is?
Yeah, so if you look, it gives you a barcode, little blank spaces, and these are the electrons absorbing the photons, and they say that is predominantly hydrogen, then the helium, and you have a very small percentage of other metals that have been fused through nuclear
It's
fusion.
particle theory, atomist theory. These are all theories. Okay, they're all theories. There's no proof of atoms or protons or neutrons or any of these. These are all theories. Okay.
Ooh, you don't accept atomic theory as well?
I don't accept atomic theory,
So
nor do I
how
accept
do
particle theory.
so how do you say that the sun is made up of electricity when, well, electricity we
I
know.
believe that the sun, moon, and stars, along with the Earth, are electromagnetic system working together. Now,
You know,
I don't have proof of that. I don't, this is just that's from what I've studied over the last couple of years. That is what I am leaning towards believing is most likely. But I say to you, we have no way of knowing for sure exactly what the composition of the sun, moon, or stars are. We cannot go to them. We cannot reach them. We cannot go and get like rocks off the moon. That's impossible and ludicrous.
you know that
Okay, and if whatever
you know that sorry, you know that the electromagnetic spectrum of photons, yeah? But you don't accept photons.
no, I don't. No, I don't think that that's telling me the composition. The sun's supposed to be a fiery ball, and I've taken plenty of photographs of it, and it does not look anything like there's fire going on whatsoever there at all. It is a light.
Okie dokie.
Any fire.
Any other questions from the stream?
No,
the
not
chat.
looking to say. Well, thank you so much for coming to talk with us. Well, we'd love to have you on again. Maybe we can talk more in depth about.
Yeah, thank you so much. I appreciate all your questions. It was awesome. I thank you for having me.
Yeah,
No,
sure. Thank you.
Thank you for coming on. Thank you so much. And if you're up to
Thank
it, you can come on again at a later date, maybe.
Sure.
Maybe
I would
go
love to. Absolutely.
more in depth about maybe particle theory sounds good to me.
Yeah, we have to.
That's a good idea.
There are a lot of mathematical things that it's kind of hard to explain over a stream, but it is easily checkable. We just have to come back and talk about it again, I suppose.
Well, mathematics is quantitative. If you're talking about atoms, particles, yeah, you can quantify them. What else are you going to do with them?
Yeah, we can talk about. I mean, do you accept? I don't know. Do you have germ theory, cell theory, plate tectonic theory, all these?
Yeah, we can
Plate
talk about anything you
tectonic,
want,
yeah.
actually.
Yeah, sure. Well, we can talk. We'll talk about theories next time and atoms and things like that.
Yeah.
Sounds great.
Yeah.
All right. Thank you so much for coming on, and we'll speak to you soon about maybe a second show. Okay.
Yeah, sounds
Thanks,
good.
guys.
Thank
See
you.
ya.
Okay, bye-bye.
Bye bye.